So in this video, we will be discussing about the versatile nature of carbon. Basically, the nature by which carbon can form many of the organic compounds. So let's start the video. We know that the number of carbon compound or the organic compounds whose formula are known to the chemist is very large. This outnumbers by a large margin the compounds formed by all other elements put together. So, if we discuss about the properties by which carbon can make so much number of organic compounds, so first of all them is the catenation property. Catenation, the linking of identical atoms together to form long chains, is called the catenation property of carbon. As you know, carbon can combine to long chain of carbon atoms to form a aliphatic or a closed chain. We will discuss about it later in the videos. Carbon has the maximum tendency of catenation. A large number of carbon atoms link with each other to form a long chain, as I mentioned here. These chains may be straight, open, branched, or closed in a cyclic ring chain. Because of the property of catenation and the carbon-carbon bond being stable, carbon is able to form a very large number of compounds. Elements like sulfur, phosphorus, oxygen, silicon, etc. also show the property of catenation, but carbon shows the property of catenation to the largest extent. Now, silicon, the second member of carbon family, forms compound with hydrogen, which have chain up to 8 atoms, but these compounds are very reactive. In addition, the carbon atoms may be linked with single, double or triple covalent bond with each other. That means a carbon can be covalently bonded to a carbon by a single bond, or a carbon can be double covalent bondedly combined to the second carbon, or they may also have triple covalent bond between them. Hope this is clear to you. Tetravalency of carbon. Since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of other elements. Thus, compounds of carbon are formed with hydrogen, oxygen, nitrogen, sulfur and chlorine, etc., giving rise to a wide variety of compounds or a very large number variety of compounds. Also, the bonds that carbon form with other elements are strong. Hence, the compounds that are formed are stable. The reason for the formation of strong bonds by carbon is its small size. Now, moving towards the next property, that is isomerism. Different compounds which have same molecular formula and molecular mass but have different physical and chemical properties are called isomers, and this phenomena is known as isomerism. For example, the molecular formula C5H12 C5H12 accounts for the following three different compounds. The C5H12, basically it is a pentane ring. It's a pentane ring having 5 carbon. You can see here it's a simple open aliphatic chain of carbon bonded with each other with a single covalent bond. Now this compound can lie in different structural forms, as you can see here the neopentane, which have 2 carbons attached laterally. Similarly, the isopentane, which have a single carbon attached laterally to the chain. Now, similarly, the molecular formula C3H6 and O accounts for two different compounds which have different physical and chemical properties. Therefore, they are isomerism. As you can see here, propanol and propanone both have C3H6 and O in their molecular formula. But if you see the structure is different. In propanol, the carbon chain is attached to a carbon which is linked to double bonded oxygen and single bonded hydrogen. But in propanol, the carbon in between the chain, the second placed carbon, have double bonded oxygen with itself. So hope everything is clear till here. Meet you in the next video.